Okay, Algebra 1, here are the last 5 examples on, or the last 5 problems on your test. I don't know why I'm stumbling. Oh, I know why. Somebody sent me a text and I had to read it. So anyway, here are the last 5 problems on the test, starting with number 53. This one is the first thing you need to look at when you're doing these inequalities is it in slope-intercept form? Y is greater than 3x minus 7 is not in slope-intercept form. So, I mean, it is in slope-intercept form, so you don't have to do anything to it. The first thing you're going to do is graph the y-intercept, which is negative 7. So we're going to go down on the y-axis 7 places. 1, 2, 3, 4, 5, 6, 7, which is the very bottom right here. And then we're going to do the slope, and the slope is 3 over 1. So we're going to go up 3 over 1, and then up 3 over 1. And then we're going to draw our line, and we're going to look to see what kind of line to draw. And since it's just greater than, we're going to draw a dashed line through our dots, like that. Yours are going to look nicer. And then we're going to shade, and since it's greater than, that means we're shading above the line, which is on this side. So I would shade right here. So I would shade my graph and make it look really nice and pretty. And that is the answer. Now, if we're going to do a test point to see whether we've graded correctly, or whether we've shaded correctly, 0, 0 is inside the shading. So if we put 0, 0 in for y and x, then we should get a true statement. That will tell us that we have done this correctly. So if we go 0 is greater than 3 times 0 minus 7, we get 0 is greater than 0 minus 7, which means 0 is greater than negative 7. This is true, so our shading in our graph is correct. Looking at the next example, you can see on 54 that it is not in slope-intercept form. So the first thing we need to do is to get our y by itself. So we'll move this 3x over here by adding 3x to both sides. So you end up with 2y is less than or equal to 3x plus 14. And now we need to divide by 2. And so we do that. The slope is now 3 over 2. And over here we're going to have 7. So y is less than or equal to 3 over 2x plus 7. So now we can graph that on our graph. So we're going to go up 7 on the y-axis, and that's right there. Do a slope of 3 over 2, which is going to go off our graph. So if we were to go up 3 and over 2, it might be somewhere like that. And I think it would make a line starting right there, because if that dot, we go up 3 over 2. Yeah, that's correct. Normally, you're not going to do that on yours, because you're going to have a graph that's big enough. Now let's look at our inequality, and it's less than or equal to, so we'll be drawing a straight line, not a straight line, all lines are straight. We're going to be drawing a solid line, so it'll look like that. And then we need to shade less than, so shade everything below the line. So I'll come down here, and I'll shade this way. So that is it. And to do our test point, again, we see that our test point would be in the shading, so 0, 0 should make a true statement. So I am going to put that in, erase all this stuff, put that in, I'll do it kind of above it here. So if we had 0 is less than or equal to 3 over 2 times 0 plus 7, that ends up being 0 is less than or equal to 0 plus 7, which means that 0 is less than or equal to 7. That is true because 0 is less than 7, which means that our graph was correct. Looking at number 55, we need to get our y by itself, remember, so we're going to move the 4 over to the right side, so let's go minus 4. And we get negative y is greater than or equal to negative 4. So now we need to, I'm going to move this 56 down here. So I'll just do this, that way I can erase it right here. Now we need to get rid of that negative with the y. So we can do that by saying times negative, or divided by negative 1, or just change both signs. And when you change both signs, it's like dividing by negative 1, which means since we divided by a negative, we have to flip the inequality sign, and we end up with y is less than or equal to 4. You're noticing, hopefully, that this does not have an x in it, which means that this is just a y line, which means it's horizontal at this number. So we're going to go up on the y-axis to 4, and we would draw a solid line because it's got the or equal to with it right through 4 like that. Since it's less than or equal to, we're going to shade below the line we just drew. So that is the graph of our line. And again, our test point is inside the shading, so we would be making a true statement if we said 0, 0 for x and y. Since we just have y, we would go put a 0 in for y, and 0 is less than or equal to 4 because it's less than 4, so we shaded correctly. Looking at number 56, we're first going to move the 2 over to the right side by going -2, and we end up with x is greater than -5. We would be adding these together since the signs are the same. And again, you're noticing there is no y in this equation, which means that this is an x line, which means it's vertical. So that's going to go on the -5, which is right there. So, and since this one is just greater than, we're going to draw a dashed line through -5, like that, and it's greater than. So we're going to shade to the right to show all the things that are greater than that line. And once again, our test point, our 0, 0, the origin, is inside the shading, so we get a true statement. So if I put a 0 in for x, I'd get 0 is greater than -5, which is true, which means we shaded correctly. Okay, look at this. We are going to get the y by itself by dividing all the terms by -3. Again, this is dividing by a negative on both sides, so we're going to be flipping our inequality. We'll do that next. So it becomes y is greater than, and we have 2/3, and then x, and then -9 divided by -3 is a +3. So I'm going to go up 3 on the y-axis, put a dot, and then we're going to do our slope from there, which is 2/3. So we're going to go up 2 over 3, like that. I'll do it one more time. Then I'm going to draw a line, and my line is going to be dashed because it's just greater than. So it'll look like this. And then it's greater than, so it needs to be everything above it. So we're going to shade up here. Now this time, finally, we have one where our test point is not in the shading, which means that when we put in 0, 0 in our equation, we are going to have a false statement. If we have a false statement, that means we shaded correctly. So we go 0 is greater than 2/3 times 0 plus 3, which gives us 0 is greater than 3. Not true, that's false, but that is what we wanted because it should have been false since the test point wasn't inside the shading. So this is correct. So yay, we did it right. And hopefully all of you guys did it right, and if you have any questions, just let me know. I will be more than happy to help you. I'll see you guys tomorrow. Bye.